For 12.1, we're talking about like 3D figures. They call it space figures, which I think is a little weird, but also known as polyhedron. So a space figure or three-dimensional figure whose surfaces are polygons. And you can see here, here's a cube. It also labels like what an edge, vertex, and face is. So this part, example 1, should be review. So the vertices are the little points where the line segments or the edges meet. So here we would have 1, 2, 3, 4, 5. That's the vertices. The edges would be right here. So 1, 2, 3, 4, 5, 6, 7, 8. And then here I know I have 4 triangles and one, this looks like a square. It looks like a rhombus on the paper or even a parallelogram, but it is a square pyramid. So we've got a square, 4 triangles, that makes 5 faces. Okay, so here for this one, faces, we've got 2 hexagons. Hexagons are 6 sides, which means then I have 6 rectangles all the way around here. So 6, 7, 8. Vertices, that would be 6. Plus 6 more. Edges, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now, the main part of the lesson is this part down here. Similar solids. Similar solids have exactly the same shape, but not the same size. 2 solids are similar if the ratio of their corresponding linear measurements are equal. Okay, now for this particular lesson, we're going to talk about like that scale factor again. So I'm just going to go from the first figure to the second figure. Determine whether the solids are similar. So that's the first thing we need to figure out. And we do that by determining if there is a scale factor amongst the linear measurements. So for example, I find this right here. So this 3 would compare to this 6. So I have 3, 6. And then this 3 compares to this 6. And then 2 would also compare to the 4. Okay, so here we have the little width of this cube. So we've got 2 fourths. Guess it could be a cube. All right, so now we reduce each one of these fractions. So 3 6 would be 1/2. 2 fourths would be 1/2. If this is all the same fraction or ratio or scale factor, then we can say yes, these 2 figures are similar and their scale factor is 1/2. Now, in the program that we're using to do our assignments, it's much easier to do a scale factor when you write it as 1:2. So either way is reasonable, acceptable, okay? So in part B, same idea. We're going to compare linear measurements. So like here, the height would be 2 and 3. Then our length, 3 1/6, and 2 and 3. Well, 2/3 and 2/3 obviously are equal, but 3 6 reduces to 1/2, and that would not be equal to 2/3. So, no, these figures are not similar, and therefore I cannot write a scale factor. Okay, now, in letter C, I believe this one is a little tricky. You're given a diameter and a radius. Can't compare those. So the radius would be 12. So I'm going to go 12 to 10. Then my height would be 30 to 25. All right, so 2 can go into 12 6 times and into 10 5. 5 goes in 6/5. And yep, that would be the same ratio or scale factor. So yes, the cylinders are similar, and they have a scale factor of 6 to 5. Okay, for letter D, we're going to compare 12 to 3, 8 to 2, and 20 to 5. So we've got 4 over 1, 4 over 1 again, 5 can go in there, 4 over 1. So again, the same scale factor or ratio, so yes, 4 over 1. Again, I chose to do 4 on top because it was the first figure to the second figure, so that's why I chose that order. All right, the next part says if the scale factor of two similar figures is A over B, then the following occurs. The ratio of the corresponding areas is A squared over B squared. This should be kind of familiar since we did this in the last one. The areas, we just squared it. But now we're going to talk about the volumes. Last time we talked about perimeter. Volume and perimeter are completely different. So volume, the ratio would be A cubed over B cubed. All right, so let's just do some basic examples here. In example 3, it says identify the scale factor ratios for each pair of similar solids. It is important to note that they're telling us that these are similar. I already know that these are similar. I don't have to try to figure that out. So then I just pick two corresponding sides. So I'm going to say, well, 14 and 7, those would compare. And for this, I'm going to go small figure to large figure. It doesn't say, so you could do large to small or small to large, and either answer would be acceptable. I'm just going to do small to large. So I'm going to say 7 to 14. And of course, that would be 1/2. So that's my scale factor. For the area, I just square that. So 1 squared over 2 squared is 1/4. And then I go back to the scale factor, and I'm going to cube it. So 1 cubed is 1. 2 cubed, 2 times 2 times 2, that would be 8. Okay. So then in part B, I've got 4 and 6. So this would be my radius to my other radius. So 4/6 reduces to 2/3. That's your scale factor. So for the area, we're squaring that. So 4/9. And then we're going to cube that. So 2 cubed is 8. 3 cubed is 27. Okay. Then for the bottom part, which I think is probably the most challenging part, but still very doable, it says identify the scale factor ratio for each pair of similar solids. Again, key. It's telling you they are similar already. Okay, so that's known fact. I don't have to figure that out. It's already known. When given surface or volume, always find the scale factor first. Okay, so here we're given the area, 25 and 4. And these are perfect squares. Okay, so I'm going to say 4/25. That is my surface area, and I can say that's my surface area because these are already perfect squares. So this is what I was given first. Okay, so that's what I was given. Once I have the given, it says find the scale factor first. So now, to go backwards, I square root. So that would be 2/5. Once I know the scale factor, I take it and I cube it to get my volume ratio. So that would be 8, and 5 to the 3rd power, 5 times 5 times 5, would be 125, I believe. Let me double check. Yes, okay. Now, for the next part, we have, again, area. So I'm going to do 375 over 960. Okay, I know I've got this area, but I can't write this ratio down because those are not perfect squares. let's say you did not know that. If you put the square root of 375 in the calculator, you are going to get a decimal, which means not a perfect square. So we reduce. And I see that this ends with a 5 and a 0, so I'm going to divide by 5. And I would get 25 over 64, which are perfect squares. So I jot those down. But to get the scale factor, remember we are square rooting both of these, and that gives me 5/8. Okay, so recap. That was a given surface area by reducing. Then I square root that to get the scale factor, but then I take the scale factor and cube it to get the volume ratio. So I've got 125, 8 to the third is 512. Okay. Part B. In this one I'm given the cubed root. Okay. So I've got 729 and 1331. Now, if you look at that chart that I had put on here for the perfect cubes, these are on there. So I am going to identify that I have the volumes, which means I take the cubed root of each one of these. Okay? So because we don't have a calculator that can do this at this moment, and I think maybe an iPhone can, I am not sure on that, but we would look at the chart, and the cube root of 729 is 9, and the cube root of 1331 is 11. So this gives me my scale factor. I did forget to write the volume ratio, so 729 and 1331. Okay, so now once I have the scale factor, I square those. So 9 squared is 81. 11 squared is 121, and that gives me my surface area ratio. All right. Last but not least, this should be A, B, C. I just realized they were all labeled wrong. So here, 162 and 384. So they are cubed, which means it is the volume ratio. Look at your chart. Do we have these numbers on the chart? The answer is no. So, reduce. So I would say we could reduce this by 6. Now here's the thing. If you automatically reduce by 2, that's totally okay. You would see that they're not perfect squares when you reduce by 2. So you'd reduce by 2 again and again. They would not be perfect squares. So you reduce, I think for a third time. And then you would see that, I don't know if it's 2 or 3, but anyway, you would see that you would get perfect squares eventually. Once you get perfect squares, you know you're good to go. So I'm going to divide by 6 and get 2764. These are perfect cubes, if you look at the chart. So the cube root of 27 is 3, and the cube root of 64 is 4. So this 3/4 is your scale factor, but that 27/64 is your volume ratio. Take this scale factor and square it, and that gives you 9/16 for your surface area. That's it.